Amazing. Thank you, Vahan. And yeah, we are the two people who will be talking here today, and we've been talking a bit so far. My name is Oscar. I'm leading the solutions team at SuperAnnotate. And to say where I'm from, I'm calling in from Stockholm this evening. And with me is Vahan. I'll let you introduce yourself as well.
Yeah, so thanks, Oscar. I'm Vahan, one of the co-founders at SuperAnnotate. I'm the CTO of the company and have been dealing with segmentation quite a lot of time in my life. Struggled during my PhD with segmentation, and then we created the company from the segmentation algorithm, actually. So good to be back with other segmentation tools. So yeah.
It's great to see how the field has evolved and how far it's come. So we're super happy to talk today a little bit more about, we're titled here Super Segment Anything, but as you most know, it's from the segmentation model coming from Meta. So segment anything. So we'll be talking a bit about that, how to improve your segmentation projects. But yeah, happy to do that today. So what will we talk about today? Well, I'll just give a short outline of what we'll talk about, a little bit about who we are for those of you who don't know, about the segmentation use case in general, some tasks, use cases, tips and tricks, and of course cover the newly released model as well. Show a bit of our platform and ramp up with some Q&A as well. And for everyone here, we'll be talking a bit today about these things. So whenever any questions pop up from you in the audience, feel free to drop it in the Q&A channel down here. So we'll have the chat for you all to talk in, but also if you want to drop any questions, do that in the Q&A field, and we'll be able to take them in the end and go through them one by one. So feel free to drop them at any time whenever you come up with them. We'll also take more questions at the end, but make sure to put them in there so we have time to answer them as well, so we don't run out of time in the end. And this session will be recorded, so we will be sharing this with every one of you afterwards as well, those of you who weren't able to join today too. And you will also be reached out by a person from SuperAnnotate with this recording, so you can always talk to them if you're looking for anything more, like want to know more about what we do, have any other questions afterwards, want to follow up, please reach out to them, or just reach out to me or Vahan as well. Anyone with a SuperAnnotate email would do. And yeah, I think that's all for today, like all the housekeeping rules. So for those of you who don't know, I mean, some of you might be already working with SuperAnnotate here, so this will be familiar to you, but those of you who are new, we're a platform for annotating, versioning, and managing your ground truth data for AI. Founded now about 5 years ago, and we've raised more than 20 million so far, and we're continuing to scale our operations. Now we're more than 150 people all over the world. So really happy to have our team spread out to be a really global team. And we are thankfully one of the, or the top ranked platform in the data labeling category on the software review platform G2. So if you're leveraging a platform and like it, you know, happy if you want to review us there as well. But I think our clients speak for us, and we're so happy to see that there. And we're also thankful for our advisors who's helped us in this journey. Some of you who are perhaps familiar with computer vision and AI might know some of the names. We have Trevor Durrell, Peter Abil from Berkeley. For those of you who might be up in the other type of generative AI field with LLMs, Peter Abil was one of the co-authors of the recently released Koala paper, for example. But we also have Gary Bradsky, like the founder of OpenCV. And if you don't want to join us more this evening, you can always join us on the OpenCV webinar in a couple of weeks, where we'll also be talking a bit more about this topic. So what do we do? Well, we want to serve you in all these use cases to provide both a platform with our data studio where you can really annotate anything, manage your annotation, the quality checks, and also the workforces, really to ensure that you get anything you want to get labeled out of your data. So that's what we offer with our data studio, supporting a wide range of data types as well. On top of that, we're also having our ML studio that helps you data scientists or computer vision engineers out there really curate, review, and draw insights from your existing data sets, and also automate a lot of different workflows and setups to ensure that you have a automated pipeline in the best possible way. And on top of this, we can really help all of you with our best practices to help with any kind of management of annotation projects. If you need to outsource, we are here to help. We have a large marketplace of vetted companies we work with on a professional level. So more than happy to help any one of you out there who might be interested in learning more and scaling your own internal projects. That's all for us. I want to keep this webinar focused on what we're all here for today as well. So that's about segmentation. And to start with, just want to make we all have the same understanding here, and anyone with different experience levels in this perhaps out there. So what we talk about when it comes to segmentation might be a couple of different potential tasks. I like to see it as the instance segmentation and panoptic segmentation tasks. And instance segmentation would be all about having a distinction between different instances of certain classes you want to have labeled. They will be labeled only of the pixels or the regions of these items and not everything else. So common data sets out there could be like Cocoa and so on. It's quite a common scenario to leverage these setups. And examples could be some kind of like mask, RCNN models and the like. When we talk about semantic segmentation instead, we're not really making any distinction between the different instances of the same class. So all the turtles have the same mask, but we are segmenting all pixels in an item. And this could be like the cityscapes data sets out there, for example, which is, we also see this quite commonly. And there's a lot of models for sure out there with different encoders, decoders, UNet, and so on. The last one, I guess we support a combination of both of them, the panoptic segmentation task, where we are making a distinction between different instances of the same class, but we're also segmenting everything. I guess this is not as common today, but becoming more and more common, I would say, out there as well.
Yes, it was more popular in autonomous driving, right? So
yeah,
and maybe in robotics. There is probably some other applications that I cannot think, but definitely autonomous driving was kind of the driving force of getting the panoptic segmentation development.
Yeah, exactly. And we've seen some, I mean, we have some robotics people here, I suppose, and it's really nice to see. And I guess this was something we have been doing quite for a long time at SuperAnnotate, and we'd love to see more adoption out there. But I think there's been a lot of more spotlight on the other tasks as of today, at least. So if you out there have the opportunity to dive into the panoptic settings as well, that would be really interesting to also hear your experiences with these kind of setups. But more than these tasks, I mean, there's so many different use cases out there. So I want to share some of our kind of, not necessarily experiences, but what we can see this for. So if you're out there looking to see like, hey, where can I apply segmentation as a computer vision engineer? It's really everywhere, right? So a couple of examples would be, for example, within defect detection, and that could be a lot of different industries like infrastructure inspection, manufacturing. And the interesting task is here, what I feel at least with our experience is that the objects are usually quite small. You have like cracks or other defects that can be quite minor on the image compared to everything you see. And the borders can be quite blurry to actually define where it starts and ends, because it might be tiny compared to the image itself, low resolution, or just also generally blurry in the terms of how you define the border of a specific defect. There might be very defined like a crack here, or it might be very general, like some kind of water damage on a wall or similar. But they might also need expertise, which is an interesting setup here where you need to have some kind of expertise labeling to actually define these. A crack might, to the right here, can be perhaps easily defined, but there are others that are way harder. And you generally want to apply segmentation here because a bounding box would give too much noise if you just have it over full of the area. And you can't really extract the area of a defect if you're looking to understand that as well, to see, say, how much of a object is actually defected in some way. Some others could be, for example, when it comes to general instance segmentation of cases of objects, we can also see that in a lot of cases like e-commerce and retail, like to the right here, to segment out different clothing options for, say, virtual try-on or similar. And an interesting setup here could be that there's many different objects, like a lot of objects in one item. Here we have a couple of these persons, but there could also be just from, say, segmentation of a retail shelf, you have hundreds of objects. This is kind of interesting to be able to handle that, as well as a lot of different classes and potential attributes. You can really dive into the potentials here, like labeling all items in a grocery store could be millions of classes for every specific item you have there. And that poses interesting challenges of its own, because oftentimes these can also overlap. So there's a need to really define the borders of both the classes, but also of the actual objects here to know where do we segment what and what overlaps which. And you don't really want to leverage, say, object detection here either, because it's just too much noise and other things covering. For example, if I would have a tie on me, that would be definitely covered in my bounding box of a shirt as well, kind of confusing models as the same.
Mm.
And I don't know if there's anyone here from the remote sensing industry, but we're working quite a lot in these scenarios as well from remote sensing data. And as you can see, SuperAnnotate is kind of industry agnostic. And we see a lot here in like forestry, agriculture, in insurance. It's really interesting to see this. And since here you really want the area as well, you understand what the area of different objects are, we're going with segmentation. So really interesting to see here. And it's an interesting topic to see how much data also could be done from synthetic data in some of these cases to leverage from that as well. So perhaps, Henrik, that is something that you're working on in terms of using stable diffusion. Really interesting topics for sure. But as we know as well, these areas can also be kind of hard to define, like blurry borders. If we have satellite data, I mean, 3 meter pixels, for example, is not uncommon for even high resolution satellites. And yeah, interesting use cases there and setups. And I think the last use case might be the most publicly known, I suppose. As we talked about earlier, these kind of autonomous vehicles scenarios that also launched segmentation out there. And I would not say like it's not only for cars, right? Like we see this for boats, robots, drones, and all of it. And it's usually about these different objects, but also drivable areas, like where can I operate this vehicle? It could be the water for the boat or the road for the car. And some, I would say, specific circumstances here could also be about how do you treat far away objects, like not something you generally always consider, but since you have this point of view scenario, you're going to get objects very far away. And if you're going to segment every one of them, you're going to end up with people with a couple of pixels only, not even distinguishable. So you need to define how to really label that with either groups or some other generic items, or not even labeling things far away. And defining accuracy is really important, not only in this use case, but perhaps specifically here, because how do you really define what a good boundary is? And I think we'll get more into that later on with Vahan as well.
Yeah, so I'll continue, I guess, the conversation about generally there is really 3 different types of like labeling approaches when it comes to segmentation, right? The manual approach, the AI assisted approach, oftentimes they call it also interactive segmentation, and model assisted approach, where kind of model is defining the initial masks. The interactive segmentation is, there is a lot of different algorithms that are helping the users to kind of refine, and obviously segment anything is probably in this segment of interactive segmentation algorithms. So when it comes to kind of manual annotations, we know that humans are extremely precise, and those are some of the good things about annotating it manually. And overall, the manual annotation tools are extremely slow, especially when you're doing it point by point. There are a few different ways to kind of speed up a little bit the speed of the manual annotation. Something like could be a lasso type of tool. Something could be like when it defines the angle as a parabola and so on. So Photoshop often have similar tool, and we have similar tools as well. When it comes to the AI assisted labeling, there is like a lot of different ways that we summarize in the article in here of different types of use cases. How do you interact with AI-assisted labeling? So there is cases with scribble-based approach, superpixel-based approach, point, kind of extreme points, and box-based approaches. And then we kind of put the advantages and disadvantages in here. And when it comes to the AI-assisted labeling, it generally speeds up the process quite a lot. And sometimes we're kind of seeing the loss in accuracy. So here, what is becoming very important is to provide a very nice and intuitive UI on top of your algorithm that should be super precise. So you need to combine those two actually to get something usable. And whenever we're talking about model-assisted labeling, then this is requiring a training model that oftentimes you don't really have the training model right away, and they can be extremely fast because you don't even interact. You just apply the model to put all the labelings, but again, oftentimes those labels can be wrong, and you might sometimes even spend more time correcting the labels rather than doing it from scratch. And then there is this trade-off in between those three approaches that we'll discuss soon in the next slide, I guess. Yeah, so there has been a great paper in CVPR that we'll cover today. CVPR is probably the best computer vision conference that is happening in June. So if you're attending CVPR, we highly recommend to stop to our booth and talk with us. But this has been actually around 4 years ago from CVPR that is talking about the importance of the label quality for semantic segmentation. So a little bit about like this left plot, what experiments did the MIT researchers is that they took cityscape dataset, they took the very, very fine annotations, extremely accurate annotations, and then they kind of use 2 or 4 different ways of making the annotations a little bit wrong and wrong. So here you can see that this is the fine annotations with amazing edges. And then here you can see that the edges are deteriorating with different parameters. So true labels and simplified labels. And the experiments that they've done, I think the findings are really, really interesting and it can be summarized in this plot on the right, which is saying that estimating labeling times in human days, this would be if you're only annotating by hand, basically. It is more or less, they plotted based on the mean IOU score, so how accurate is the model. And what they found out that when you're doing very fine annotations, with more data you have, obviously you will have more and more accurate models. But interestingly, when they're mixing the data set of very fine annotations with 3,000 fine annotations with coarse annotations, the accuracy is getting as high as you can see it in here, or even slightly higher, which is kind of crazy, right? Then if you would do the fine annotations. And then when you're looking at this plot, this is a logarithmic side on the x-axis. So instead of, I don't know, 200 days, you can spend more or less like 5-6 times less, but then achieve the similar type of accuracy. On the other hand, you can also do like less fine annotations, and then they kind of mix those, and you can see that even with coarse annotations, if you're only doing it that way, you still get more accurate models. But if you want to reach a really high level of accuracy, you need to mix the data sets between coarse annotations and fine annotations. Kind of why we're talking about this paper, the lesson is sometimes some of those AI models are good enough, they are capturing the edges kind of good enough, but they're not really ideal. If you want to further improve the accuracy of your model, you probably need to kind of do a mix of like, I don't know, 10%, 90%, or 80%, 20% of fine annotations, and then model-assisted labeling. And that will probably help you to decrease the time on your annotation efforts, and then increase the accuracy if you're really trying to hit some of those 95, 96% accuracy levels, right? Yeah, any comments, Oscar, on your end?
I think it's a very good point. I mean, I think it's worthwhile for everyone to think about this before defining like pixel perfect accuracy as the requirement in the label data set. Might not be needed, right? Having this kind of combination is really interesting to see. And yeah, I think it kind of pairs well with a lot of the other solutions out there as well. And I see other questions being dropped here in the chat and so on as well. So we'll definitely get to all of those. And for anyone who's kind of joining now, we'll talk about now going into the segment anything model and talk a little bit about that. But if you have any questions, just drop it in the Q&A channel. We'll get to all of those at the end of the webinar and cover them. And if you come up with anything else, always feel free to drop it there as well. But right, I mean, this is what we're sort of here for today as well, the segment anything model. So before we go into the demo and show what it looks like on our platform, I'll just go briefly over what this really is. Like, what did this research team create? Well, when they termed it, they talked about like taking some of the foundational model from NLP and bringing that to the segmentation space in computer vision. So as we've seen with a lot of these LLMs now, they're trained with some kind of, you have a prompt, someone writing, and you get a generated response back. And they took that idea and set it in a segmentation setup instead. So instead of having a written prompt of something that you want to chat with a bot with, you have, for example, points on a image, you have a bounding box, a rough segmentation, even some kind of free text input or a example there, but that's still in like a research phase from them. But this is what they're taking, and the output, instead of having an answer to the question, would be just the mask output, right? So this makes us have a defined task to get a valid mask out of it. So different types of input, and they can be very subjective, as they are in the case of chat prompts as well. I mean, as we take a look at, for example, the image to the right there, when we select a point on an image, it can mean a lot of different things. We can have, for example, the full ostrich, the upper body of the ostrich, or just the face. And same thing for a lot of other examples as well. So we're dealing with this setup where it's a bit obscure exactly what the right answer is. And we're just trying to see a model that can generate something plausible out of it. So what does the model itself look like? Well, what they developed is a setup where they're running a image encoder first on the image that you have. It's a visual transformer where they're encoding the image embeddings. And this can be run offline as well, or like pre-computed for the data too. And since they have a lot of different types of potential prompts, they're also having an encoder for the prompt itself. So you're combining the image encoding and the prompt encoding with a lightweight mask decoder, and they're outputting 3 different outputs of the mask itself with different confidences. So since it is subjective, again, you are able to kind of select between these because they're not necessarily right or wrong answers. They could just be the answer to different setups here. And the setup here itself can be generally quite fast, especially if you do the image encoding beforehand. And yeah, I would say that's about it of the model itself. And they used really this model to generate the data set as well. So we can go more into what they did with the data set, because they did create like the largest segmentation data set out there. They're calling it SA1B. So 11 million images, 1 billion masks from this interactive model assisted or AI assisted labeling setup. And during labeling, they really increased the annotation speed from 34 seconds down to 14 seconds when labeling a full image. And even 14 seconds is like 6.5 times faster than the mask annotation that was mentioned for the COCO dataset. So they really show that this not only creates a good dataset and is a good segmentation model, but it also helps in labeling this type of data. And how they gathered this is like, initially it was mainly a manual approach where they label the data, then they put in the model itself here to have some suggestions for the labeling, right? Have semi-automated setup. But in the end, when they actually gathered all of it, they just used the automated setup and automatically annotated the whole data set, all of the 11 million images. And the images themselves are kind of high resolution originally, taken like from photographers from different places all over the globe, but they've been downsampled a bit to 1500 pixels on the shortest length. And the masks that they generated, like 99.1% of the 1 billion masks are automatically created. But this kind of 0.9% that is not automatically created, but in the manual or semi-automated step that was used to kind of fine-tune and retrain their model is not really released to the public. They are just releasing the fully automated data set in this model, the fully automated generated masks. So there are no classes of this data set, it's just generic masks that are separated in like an instance segmentation fashion. FAIR, like the research center, also did a responsible AI analysis. So the datasets should be quite geographically diverse and also quite fair in the segmentation of different people, of say different ages, sexes, and ethnicity. So they've tried to improve on that part as well when it comes to this. And that's kind of what they released and what has been open sourced and what we're building all of this upon in one way. So, I mean, this is what they have, but I guess we've done some small things to make it more usable and improve it as well, right?
Oscar, I was checking the masks, actually the auto-generated masks, and then I felt that if you would improve those masks, some of those masks are not really the best quality, and so much could have been improved, you know, so it's really interesting to see, and they could probably mix those like fine annotations and coarse annotations as well.
Yeah, I mean, labeling this kind of 1 billion masks would take forever. So I think it's interesting because they shared some information about the mask quality, but they basically sampled like 500 images and improved the quality of those with their own annotators to get it more pixel precise. And then they just compared the IOU scores of that and the automated version. And I think they found that like 94% of pairs had greater than 90% IOU. So yeah, it seems decent, but as you said, like it's definitely absolutely possible to improve it quite a bit.
Yeah. Well, as we're talking about the improvements, let's talk a little bit about the improvements that we did. We integrated segment anything on our side. And some of the things, especially on the instance segmentation side, what we did is like we kind of solve a lot of the latency issues, because even if it's like 200 milliseconds, that is kind of, it is creating a little bit of an unpleasant lag that when you're annotating, it's kind of not that great, and you want to have like almost like 10 millisecond gap, right, instead of 200. As a result, we're kind of providing a faster annotations, and then quality is also increasing in some cases, because as we'll do the demo, sometimes you're kind of not really catching the object. You need to click and then you need to do a negative click. We have a different approach on that side. So let me go to the next slide, which is our demo slide. So I will switch the screens and then go for a demo.
Malvan is switching, like continue to drop questions here. I see that we have a couple coming in here. That's great. I think some of them might be answered when we do the demo, but just pour them in there. We'll get to all of them in the end as well. And if it's about us, the model, anything else, feel free.
Yeah, so what I did, I took down a lot of segment anything original images and then create a project in here. So let's jump on this image and we'll do a quick demo in here, and then we'll talk what are some other ways of improving the annotation mask and when you're doing a quality check. So if you're familiar with our platform, I guess this is how our image editor looks like. There is a lot of different tools on the left side. So there is a lot of manual tools that we have. There is some semi-automatic tools that are Magic Polygon and Magic Box or Magic OCR. And then we added our Magic Select, which is more or less segment anything. It's working segment anything algorithm under the hoods. And when you're clicking on it, we have a nice visual that it kind of sends the image back and then receives the data. And now you can see that all these latency issues that we're talking is very much not really present, because if I don't know if you're having the same feeling as watching the video, but it's very fast. And in some cases, when you want to kind of kind of, let's say, annotate all the bananas, then it will be 1, 2, 3, 4, 5, and then 6. And then in some cases, you can see that it is selecting the 2 and it didn't really find one. And in such scenarios, segment anything is allowing you to click and hover and then do a positive and negative clicks. But oftentimes it's a lot faster of like scribbling and getting a lot of positive clicks and catch that region a lot better, rather than kind of click, wait and see what's going to happen, and then click negative, click positive, when you can kind of scribble it, and then you will get a lot more points, so to speak, to give the information for the fast annotation. The other thing that we did is, like, sometimes when you're hovering on the image, then I want to select the entire spoon, let's say. And in this case, either I can go down, but sometimes maybe in here I can show. Here it doesn't really pick it, here it doesn't really pick it. So there are a lot of different layers, right? So if you want to kind of change the layer, then you can easily click a shortcut, which is the Option button on Mac, or I guess Alt.
I think it's the Alt, yeah.
Yeah, Alt in Windows. Then you will be able to switch very quickly between the layers. So if you're only interested in spoon, that's going to be very simple to annotate. And same thing will be in here. And same thing, I guess, will be in here as well. So if I want to select the entire thing. Great. So let's say, as we annotated a lot of different images, items on our side, we can go back to our project management side. I think there is a small thing that should be fixed now. Yeah, so, and then what we can do is actually go and have our Explore view to see how our data set looks like, have a more better, more closer view, so to speak, on what we have annotated. So we have this fashion segmentation data set, as Oscar was mentioning, and when you're gonna go to Explore, then this is one easy way to very quickly zoom out on all the segmentations that we have, and very quickly see whether the annotations were done correctly or not. So sometimes what you can do in here is that I'm not really interested in all the classes. I know that shoes are some class that my model is failing. What I can do is I can turn off everything, and then I can search shoe in here, and we'll apply the filter. So what this will do, it will go ahead and then find all the shoes that we have been annotating one by one. So right away, I can very, very quickly see some inconsistencies within my annotations, because sometimes one shoe is annotating as one instance. Sometimes they annotate both shoes. So what we really want to get a really high quality predictions is consistency in the annotations. Instructions are super important when you're mixing those. Those are almost way worse than when you're annotating a few pixels worse here and there. And same thing you can see here. I have an instance that is connected with two shoes, but then if I will scroll a little bit more, let's see, same problem. And now I can see that sometimes there is a shoe that people excluded some regions, which is the skin, for example, of the human. But in some other cases, they haven't done that. So those are also some of the inconsistencies that you can really catch very, very quickly in our platform. And then this is another use case where they took the shoe and then they divided into 3 different segments rather than just one segment. So we were able to catch really 3 different mistakes right away by just simply looking at this data set. And what probably you need to do is go ahead and then fine-tune your instructions, include all these edge cases, so you can get really high quality models for your data set. Yeah, and then one last thing on the inside side. So on our end, you can kind of slice and dice your data set and get analytics on anything that you're looking for. So one interesting thing would be, well, what's my annotation speed, for example? I want to check it over time. So here in the breakdown part, I will say that I want to break down by the annotation date. And here, instead of count, I want to see, I think, annotation time. And instead of summarizing all the annotation times together, I want to take the average of them. So here you can clearly see that, oh, you know what, on average, it takes like 100 seconds, I don't know, 130 seconds to annotate an image or so, but there has been one day that the annotators has spent like 5x more or 4x more. So there is a clear outlier of something is happening. So you will have an easier time to catch mistakes like this. And some of the other information can be not really image-based, but an instance-based approach where you can see your class distributions. So here you would see that, oh, I have a lot of shoes annotated, but maybe if my model is failing on watches and I don't know, blazers, let's say, or earrings, then I know that I have such a little amount of data set that I would rather find images that are containing those particular classes. All right, I think I will stop the demo in here. Yeah, please drop any questions that you have on your end. We'll then move back to our presentation, and I think we're close.
Exactly. I think we're getting to the questions quite soon. I just want to share some numbers here of coming from our clients and how they have leveraged SuperAnnotate in some of these sessions, or sorry, some of these features like our curation to really help with their project. So we have a client who used to spend up to like 3 days to do quality control of their data, but with our system, they took that down to 3 hours instead of a specific batch of data. And from others that did some comparisons between previous systems, they were able to do 32 times faster quality assurance based on their previous tests with other systems and their feedback. And all of this has resulted in more than 50% savings on their annotation budget itself, because they enabled better QA, improved revisions, and could improve the project at the start and continue to have high quality with lower costs. So I just want to share that with all of you. And that's what we have today. So thank you all for joining. We'll get to the questions. So what we talked about today is just all about segmentation, right? How does it work with different setups, different use cases, all the industries, covered very good tips and tricks. So the takeaway there is to think about your quality and how you define that, and if that is what you actually need in terms of pixel perfect quality. We also covered SAM, like how we can do, or how it works, and also how it works on our platform. And lastly, we talked about the curation part, like how you can improve your curation and QA for segmentation datasets to save both time, money, and mislabeled datasets, really. And that's all for us today. Really appreciate all of you joining here, staying till the end. We'll get to the questions now too. We'll take a look at it. I know some questions have been dropped in the chat, some in the Q&A box. I see some questions related to integrations about different data types and the like. Perhaps to start off with the oldest question we have here, starting from the start. It's all about remote sensing data. I know we covered that use case a little bit, and that data can be very large. That's like one of, I think, the key components we see there, very large images, high resolution. And depending on the system you have, what you want to do, we might see some cases you carve it up into very many different tiles and you label them totally independently, right? You just tile them up and label them, but sometimes you need a context, or you need to have objects that span over multiple over multiple different tiles. And in some cases, what we've seen is that for segmentation tasks, you can still do it in the separated tile fashion to kind of parallelize the work, since segmentation in semantic sense, for example, usually match up. But if you're doing object detection or some kind of instance segmentation, you won't have the context and everything in one tile. And we do have a specific editor in our platform that does support this fashion. So it will have an it will have a tiling system that ensures that you can just see the high-res images from afar and zoom in to get higher resolution at different points. So it's like Google Maps in that sense, leveraging a deep zoom library to focus in as you zoom and enabling you to really have high resolution images and these segmentations on those without losing any performance issues there, for sure. I hope that answers your question, Rafael, and we'll be more than happy to kind of show that to you or anyone else interested. If you're looking to have a demo with us, just reach out. We'll be happy to talk more about that and show it live as well.
Yeah, maybe I can cover some of the questions. Arik is asking how we're assigning the classes. So more or less, this is a class agnostic in some sense. If you know your classes from the beginning, let's say in here, if I know my classes, then I select the class in advance. Let's say I want to select, I don't know, something like a chair, and then I will be able to kind of annotate the chairs right away. So it's a pre-selection of the classes. It's class agnostic, and if you select no class, let's say in here, then it will become something without a class. So hope this helps. We had another question. I will try to read the short ones, Oscar. And then
yeah, I think this was sort of related to another one, like how we do set up these classes as well is just that before you're starting a project, you're defining which classes would be available for selection. So that is something that you'll be able to define at first when starting a project, and then that will be the selection that you can select from, let's say.
Yeah, something around here, I guess.
Yeah, exactly.
We have a question about if it's working in real time. So, I mean, it takes a second or two until we get the answer. So sometimes when you're doing segmentation, obviously kind of digesting what's in the image is taking a second or two. So kind of clicking on that, pre-processing and then getting the segments is more or less taking a few, 1 or 2 seconds. And then after that, you can really annotate in real time.
Yeah, so the segmentations here are quite real time in that sense, but we are also, like we talked previously about the model assisted one, that's also something you can run with SuperAnnotate, kind of upload any kind of output from your models and just do corrections on the platform. So we have the trifecta there of both the manual, the AI assisted with different baseline tools, because as we show there, sometimes segment anything works best, sometimes the magic polygon is better, but you can also just start out working from your model predictions to correct those as well. One question here is about medical image segmentation, and it's absolutely something we do here as well. So you can absolutely leverage this for medical image segmentation. We've done a lot of projects there. So also if there is a need to kind of scale the operations, I know that getting the hands on doctors to do labeling can be hard and they're not always too willing to do that. So we're always more than happy to help in those scenarios to kind of scale the annotation efforts to get the correct expertise to label the data there as well. So we absolutely can help with the medical part.
There was a question about bounding boxes, if we can generate bounding boxes. That's one of the future plans, because sometimes this is even faster to kind of do a bounding box annotation rather than putting a bounding box, you hover and click. So kind of extracting the local maximums and minimums of those segmentation max will really allow you to do the bounding box annotation. So, but that's more on future plans.
See here, there's so many questions to select from. Perhaps one thing is a very early question about super pixels and the techniques based on that. I don't know, Van, if you want to talk a little bit just briefly about it, because it's basically how we started the company in one way. So there is some experience in that field as well.
Yeah. So we started the company from my super pixel algorithm. At the time, it was state of the art, and it was 2018. And fast forward 5 years, I think we're using it still in our semantic segmentation task, where it is extremely important to have edges, not really miss any pixels between the edges. And that's some of the use cases that we're using the SuperPixel. And when it comes to instance segmentation, though, I have to admit that Meta is beating my algorithm big time. So that's why we're kind of open of doing the switch and integrate the state of the art of that time.
Great. And thank you, everyone. I see people dropping out. Thank you, everyone, for joining here. We'll stay a bit longer to cover some of the remaining questions. But thank you all for joining. And yeah, I'll get a email with the recording later on, or reach out about it and get in touch. So if you have any questions, always reach out back to us. We can cover more individually with any one of you as well. I see some questions here, a couple related to videos, and we do also have a native setup to support video annotations. We mainly see cases of object tracking doing there, so we have a very good system to enable you to track items very smoothly in very long videos as well. So in our system, you can stream a direct video to the platform and label it, and with our setup there, we're able to, compared to others, generally stream longer videos with more instances without any kind of degraded performance of the annotation platform. So yeah, we can leverage this in videos as well for any kind of object tracking, but also we have cases there for segmentation as well.
Yeah, small addition there, like on the automated tool side, we're just going to release now our automated object tracking for bounding boxes, and later during the summer, there will be also a segment anything tracking, meaning that we will be able to very accurately track different objects across different frames.
That's great. Yeah, and there is a couple of questions here related to, I guess just a small add-on there as well. Yeah, we're doing a lot of development all of the time with short development cycles. So what you see today will be very much improved shortly as well. So we're taking a lot of feedback from our clients, our partners, of course, anyone looking to give feedback, and happy to hear that. So if there's anything you really need, well, shout it out, provide it to us. We're happy to hear. And as Juan said, there's a lot of interesting things coming soon as well. This is just one of the more recent releases we've had. I see some questions as well related to how to get access to the platform. If you're interested in that, please reach out to us. We're more than happy to talk to you how that works and provide access. So just reach out. You can schedule demos with us through our platform. We can talk a bit about the platform works, show you the ropes. So just let us know there.
Small question about how can we define a custom output format. So we have a very detailed JSON output format that you can kind of write a small Python script to customize to your needs, whether it's like, I don't know, Coco, but Coco is natively supported, or some of the other segmentation mask formats that you want. So we do provide an SDK that's more or less, it's kind of helping you to connect with our platform and do all sorts of automatic things and communicate with our platform with your code. So that shouldn't really be any issue there. Yeah, hope this answers.
Yeah, we see like thousands of different custom formats. So we have our own, as one said, that covers a lot, but you can really define your own conversion functions in these setups as well. And we can also help in some cases here. So for sure. I think a very interesting question here, I know we need to wrap up soon, but one thing here, there's a question from Alexander about, would you say there is a before and after segment anything? Is it a major revolution here on this size? And I mean, I love to hear your opinion on this. For me, it feels a little bit like this is a great model out here, and it's interesting to see how they trained it, but it's still one in a long row of models that does segmentation and not necessarily a huge leap in any way. It builds upon other things and it's very good, but it also has its own deficiencies and will not absolutely cover everything. I don't see anyone going out of work after this, but it's absolutely a great setup. Or what do you think?
Yeah, I think the big breakthrough that it did is object agnostic side. I think it's performing amazing, much better than what we had anything before. But when you're training the specific models on cars, let's say on humans, then we can have like a lot of models that will obviously be a lot more accurate than segment anything. But that kind of requires a lot of time. That's why as an annotation tool, this is a perfect candidate to kind of help you to annotate faster for whatever data set you have, whether it's mining, medical imaging, I don't know, in agriculture and so on.
Yeah, thank you for the great questions. And do we have time for more? Let's see if there's any questions we have time to answer. Right, let's see here. Automatic annotation. Yeah, I mean, I think when it comes to different automatic annotation, I think there's a lot of questions about different models and automatic annotation solutions and so on. Generally, what we have on our platform is currently these different setups that you can run object agnostic for the segmentation. You are also able to train models on our platform. So you would basically train a deep learning model to do these kind of tasks, but that would be more in the model assisted labeling section. So you will be able to train your model. We see most clients train model on their own end. So you can train it locally or whatever cloud you have and just set it up to run the predictions towards our platform. And you can start from that scenario instead of the model assisted labeling. So that's generally how we see some of these setups work, and that would connect to a lot of different tools out there like YOLO models or other things.
Mm-hmm. And for like very generic use cases where you want to very quickly prototype and check how the model accuracy is working, is I think you can also do it in our platform, right? Create a model, get the accuracy, test it on a few images. But if you're looking to kind of put that in production, we generally suggest you to customize a little bit the parameters, because oftentimes the generic models are great. More mature ML engineers know how to kind of improve those generic models. So we kind of give the both of the world.
Exactly. And especially if you're looking to run the model with some kind of specific inference time or run it on the edge or something, our models there are more designed to give great prediction quality. So it can help in the annotation process. So you run it in a big batch and you can then improve that. So these models do not run the fastest, which is not a problem in the scenario of assisting in the labeling effort. But if you're looking to run something more real time, yeah, then you might want to pick and choose a little bit more extra or squeeze the models perhaps to have them more deployable on your machines.
Mm-hmm. There is a question about, is it possible to integrate a YOLO technique to the image toolkit to have custom labels for segmentation? I think, if I'm not mistaken, one of the latest YOLO versions is supporting the segmentation as well. So if you would, I don't know, semi-automatically or manually annotate a few hundred images, then you can easily kind of integrate those with those new YOLO models. YOLO is such a kind of large term nowadays that it is hard to answer more or less very specifically.
All right, I know that there's other questions as well here. I don't think we'll have time for all of them today. We'll try to reach out to everyone, and if there's anything we missed, anything you're looking to learn more about, please reach out, talk to us. We'll be more than happy to discuss with you or show you more of our platform, what we do, talk about your use cases. We're always interested to hear what the community out there is doing. So please reach out, get in touch with us, and learn more about what we do. We want to learn more about what you do, see how we can collaborate and help. So thank you everyone for joining this webinar, and hope you have a great evening, morning, lunch, or wherever you are right now. Thank you.
All right.